Hello everyone, very good morning. So today let's try to understand the LeetCode problem number 3130. So this problem number 3130, it's a hard problem of the array 1, right? So this is array 2 and array 1 we have already seen, okay? So let's try to understand this problem because this problem is very interesting because as we know, yesterday we also have used the DP approach for the array 1, right? And this problem is also based on the dynamic programming, right? Here we have to find all the possible stable binary arrays too, right? So if you go through this problem, right, the problem looks extremely complex because of the constraint that we have given in this problem. But when you understand the pattern restrictions and the DP trick, right, you will feel that, oh, this is very, very easy. Okay. So in this video, we will cover almost everything like problem, example, intuition, and the dynamic programming approach. Okay. And finally, we'll understand the Java implementation. So let's get started and try to understand everything that we will talk about, uh, the problem, intuition, and the example. Everything we will understand here, guys. Okay. So let's try to understand one by one and we'll solve this problem. Okay. So let's think again. The very first, what the question is saying here, right? The question we have given three things we have given. Okay. Very first, we have given three values. We have given, let's call, we have zeros we have given. So this zero is nothing but the number of, we can say, zeros. Okay. Then we have given is 1. This one is number of ones we have given. Okay. And then we have given the limit we have given, guys, right? So this limit is the maximum number maximum number of same consecutive numbers allowed, we can say. Okay. The very first we have given is 0, then 1, and the third thing is limit. So these three things we have given. And what is our task? Our task is to count how many binary arrays we can build, such as the array contains exactly 0 zeros, right? And the array should contain exactly 1 ones, and there should be no more than limit identical consecutives, right? So that we have to follow. Especially, let's suppose that we must avoid the sequence like, let's call 0 0 0 1 1 1, like that. We should avoid that. Okay. So let's try to understand what the problem is saying that, right? So let's suppose here. So if we have given some inputs we have given, okay. So let's suppose the example that we have given, okay. The very first we have given is number of zeros we have given is 1, number of ones we have given is 1, and the limit we have given is 1. Okay. And if you go through the approach, you will see that this is the value is coming. Okay. So better let's start taking example. Let's say that we have given 0 is 1, we have given 1 is 2, and limit is this time we have given is 1. This example is good. Okay. Let's think that these three things you have given. Okay. First, second, and third thing we have given. Okay. What will be the possible permutations? Possible permutation is what? We need only one zero. How many zeros we required? Only one. So we'll say, okay, 0. How many ones we require? 2. So we can say 1 1. The limit is only 1. Okay. Then we have is 1 0 1, we can say, and 1 1 0. So these are the possible permutation. Possible permutations, we can say that, right? Now, if we'll apply this rule, let's apply this rule on these things. Okay. What is the rule is here? The limit we are talking about. Okay. So here 1 1 contains, here 1 1 contains together, right? Consecutive. It means in this case, this is not valid, this is not valid. Only one thing is valid here is we have this is valid. Okay, so if we say here why it is failing, because it contains the very first part, this one contains 1 1 together, and that is why the limit fails here, right? Similarly for this case, but 101 is alternating, right? Here alternating 1 1 is there, so it's fine, it's will work. Means there is only one valid array is 101, we can say that. Okay, so you should understand what the constraint we have given, right? So the difficult part of this problem is how you will control the consecutive identical number. Okay, so while building the array, we must track how many zeros are there, right? And how many ones we have used, right? How many zeros we have used, and how many ones we have used, and what was the last number that we have placed. Because if the number was zero, right? Let's suppose zero or one, right? So if the last number was zero, another adding zero, right? Again, it will make the array invalid, right? Or if you'll add another zero, it means it might validate the limit, we can say. Okay, so these natural things leads the dynamic programming problem, right? And that gives you a very understanding DP approach. So let's try to understand here. Let's understand the thing that we are talking about. DP state we will understand. Okay, so think that what is our DP state. DP state should be what? It should be DP, let's suppose we have a DP I, J, and the last bit. Three things we will use. Okay, I, we know that this will be the number of zeros used, zeros we will track, right? And this J is ones we will use, and the last bit is the last element in the array. Either it is 0 or 1. Understand? Means if you'll talk about, can we re-represent this one? Like let's suppose dp at 2, there will be some element is 1 and 0 or 1. So this array is used, means we have zeros, let's suppose is 2, 1 ones we can say, and ends with 0. This is the meaning of this array. Okay, so now if you understand this DP state, right? Now we should understand the DP transition, how the DP transition will happen, right? That is also very important thing here. Let's understand DP transition. Okay, what is DP transition? So now if you want to build the transition, right, very first thing that there will be two cases. Either the case one, that ending with 0, right? Ending with 0, we can say that. Okay, and or we can say remove like ending with 0. Okay, so if the current elements or array ends with 0, we must have added the 0, right? So the previous state could be what? Previous state will become what? DP I minus 1, J, and 0. There is two possibility. Either this will be there or DP at I minus 1, J, or 1. Correct? These are called the previous state. If these two are the previous state, right? If these two are the previous state, give me 1 second. Yes. So this is nothing but, guys, previous state, we can say that. Okay. So these two things are previous state. If the it ends with the 0, if the current element, current array ends with 0, it means we must have added 0. Correct? So the previous state could be either I minus 1 j 0 or I minus 1 j 1. So when we write the DP, let's suppose the DP at I, j, and 0, right? The value, we have to do the sum of these two things. So this dp at I minus 1, j will use, and dp at I minus 1, j 1. So these two things we have to add it. Okay, let's say that we'll write dp at I minus 1, j 0 plus, same thing we'll write, it will become 1, right? So this is very important, guys, never forget that. Okay, because if you want to find it, dp at ij and 0, you have to write like this. Okay, but this count sequence like 0 0 0, right, which may exceed the limit, right, which may exceed 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 the limit. Okay, this is the thing you have to understand. Means, to remove invalid sequence, we must subtract what? We can say dp, you write I minus limit, I minus limit, or let me 1 second, I minus limit, guys, and 1 minus 1, and there will be j, and there will be 1. So we have to remove invalid sequence, we can say that. Then we will use this thing. Okay, I hope you're understanding. Means this removes the array that could create more than the limit consecutive zeros, right? Let's think about when we write with the when it ends with 1, right? Let's understand case 2. Case 2, when it ends with ends with or ending with 1, right? So when it's ending with 1, it's very simple that you just write dp at I, j, and 1, correct? But here it will become what? dp at I, j minus 1, and 0. Here you will write what? A plus dp at I minus j minus 1 and 1. Similarly, right, we have to write like this, correct? So this will give if it is ending with 1. Okay, so you have to also avoid too many consecutive ones, so we have to subtract, right? If we have to avoid consecutive, right, consecutive. Okay, in that case we have to subtract. What we have to subtract? dp at I and j minus limit minus 1, and this will be 0. So this part you have to subtract, right? So it's keep the dp very efficient, and that will build the complexity in very compact size. Means we only need the dp, we can say 1, we need 0 plus 1, right? And there will be multiply 1 plus 1, we can say that, right? Two things will be there. Okay, and similarly for the space, you know that 0 plus 1, not plus 1, multiply, sorry, right, like this. So this will be your sc of this, and your time complexity of this, right? So because this will go maximum up to 1000, right? If we'll do, if even it works fine, right? So let's try to go through the code, you will understand. So let's try to implement. Okay, the very first thing that we have given the, what you call, 0 1 and limit we have given, right? But we have to also take the mode, right? So what we'll create, very first we'll create final int mode. Okay, and here we know that we have to write how many, uh, 3 times, and then 3 times, and then 0 7, like this we have to take the modulo, right? Means if you understand this, right, we need 30, right, then 30 and then 7, right? Three things we have to do, correct? That we have to do. You can take the underscore also, that we have done study, right? Like that we can also do, but it's okay, not we'll keep like this only, okay? Then we'll create int, array and array. 3D array we need, and dp. So this dp will be initialize itself here, like int, and we'll pass the what are the number of zeros we have given. So 0 plus 1 we can say that. Then we have the 1 plus 1 and the limit 1, okay? So for the limit, we will not use directly here, because we either there is possibility the last bit we have to use, right? Last bit will decide the limit, right? The consecutive limits we can say that, okay? So here we will use 2 bit, 0 or 1, okay? So like that we will use. It means we want to iterate int 0, int I is 0, int I is 0, and I should be less than equal to 0, correct? And I plus plus. Similarly, we have to go for all the elements, right? So int j is nothing but 0. J should be less than equal to 1, and j plus plus, right? So this two loop is required as a. There will be another loop that is for the last bit, right? Because this is 3D, guys. So you have to take in last bit, we can say. Last bit will start from 0, and this last bit, it should be less than equal to 1, and last bit should be plus plus, like that. Now we'll say if I is equal to 0, what we will do, we'll say if last bit is equal to 0, and not and or, if j is greater than the limit. Now tell what will happen. So if last bit is equal to 0, it means we have to set the value. How will you set the value? We say dp at I, dp at j, ij, and the last bit. What is the last bit we have taken here? The last bit itself we have written here. Ijk we can also take, but it's okay. We have to also understand. Okay. So this is the case will happen where we'll write last when last bit is 0. Oh, sorry, last bit is 0 here. So we'll write 0. Okay. It means else condition, what will happen in all the else condition, the dp at I, j, and the last bit. So this value will be 1, right? It should be 1 in else condition. So when we saw that if I is 0, we have to say this one. Again, we'll say, okay, what is else if? Else if we say, okay, if j is equal to 0, then what will happen? We'll say, okay, if the last bit, if the last bit is equal to 1, or I is greater than the limit, right? Similarly, there will be possibility. It means dp at I, dp at I, j, and the last bit, right? So this last bit also will be there, and this last bit become what? This last bit become 1 here, right? No, last bit is uh, okay, when j is 0 0, right? Then what we have checked, the last bit is equal to 1, right? I should be greater than limit. It means the dp at I, j, and the last bit should be what? It should be 0. correct? In else condition, we have to provide that dp at I, j, and the last bit. Okay, here you should provide 1, right? Just opposite to the previous one we have to do, correct? Now think that once this is also done, there will be what? There will be else if. In this condition we have to check, okay, if the last bit is 0, then what we will do? Then we'll say, okay, let's do that. dp, we have to check I, j, and the 0. We have to set here dp I minus 1, j, dp I minus 1, j, and it should be 0, right? Then we have to do plus. The same thing we have to repeat dp I minus 1. We can say I minus 1. Then we'll take the j and one bit, and another bit will be 0. Another bit will be 0. So these things we should understand. Okay. Now we have check that we have updated this value. Now we have to check the limit also. Is I is exceeding the limit? It means we have to avoid the uh, limit, right? We have to remove that we are talking about, right? So we'll say dp I minus, not I here, it should be I, j, and 0. Remember? So here you will write dp I minus limit and minus 1. Remember? This part you have to do, and similarly you have to write j and 1 if I is greater than limit. In other condition you have to also write that if there will be else condition. Okay, if there will be a else condition, just think that if there will be else condition, and we'll say, okay, the dp I, j, and 1, I, j, and 1, if it is dp I, j minus 1 and 0, right? In this case we will just add I, j minus 1 and the 1. These three things we will add, and we'll say, okay, similarly we'll check if it is j is exceeding the limit, guys, right? Remember that we have talked about. It means we have to update that. We have to remove actually the same thing we will do I, j, and here it will be, last time we have written 1 and 0, so it will be 1. Okay, so we will take what in the case of once, if it exceed, right, means we have to remove. So we'll say, okay, j minus limit and minus 1, and we'll say this is 0. Okay, so like that we have to keep moving, and we have to maintain. Once this if condition come finished, right, what we need to do, we have to take the modulo, right? So we'll say, okay, dp at I, j, and the last bit, we can say, right, last bit we have to take the mod here should be equal to the mod we are talking about. Okay, there will be also one condition where you will say, okay, if our the dp itself, dp at I, j, and the last bit, If it is less than 0, in that case, we should say dp I j and the last bit. Okay, it should be nothing but plus equal to the mode. Okay, it's very easy, guys. Let me check. One return statement is failing. Yeah, so when we come here, right, it should be here. The return statement should be there. Okay, so you need to just pass a return and we'll say, okay, what is our dp contains three things: 0, then we have is 1, and another is bit. If it is 0, add 0, then we have to add one more thing: dp 0, dp 1, and 1. If you'll do the sum, then you have to take the mod, right? As simple as here. So you just pass this part, it will work. Okay, let's check. Okay, so let me go through the very first that we have used the mod, and this mod will contain this. How many zeros are there? Let's check. It should be how many? Let's check. Okay, yeah, 1 0 0 0 0 0 7. Yes, correct, perfect. Then we'll use 3 times 0, 3 times 0, again 3 times 0, and 0 0 7. Okay, then we'll use dp will use zeros plus 1, ones plus 1, and the 2 bits we will use, right? Then we'll take I and j. So I should go to till the 0, the 1 should go to till the j should go to the 1, and the last bit that we'll use is also will go from 0 to the less than equal to 1 bit only. Okay, the very first thing is that we will check if I is 0, we'll check last bit is equal to 0 and j is greater than limit. So dp at I, j, and the last bit, right, it is, if it is the 0, in the else condition it will come 1, right? Then we'll create the else if, right? We'll say j is equal to 0, means we'll check if the last bit is 1 and I is greater than the limit, it means it's stored the 0, otherwise stored 1, right? So this thing we have to maintain if j is equal to 0. Now we'll check if the last bit is 0, so we have to maintain this dpij and 0. So we'll update the dpi and 0, right? dpi and 0 we will maintain. We'll check if the I is greater than the limit, so we have to update this value. So here we have to do, we have not reduced the thing, we have to reduce with the minus, guys. Okay, if you do the minus, then it will update the value. Okay, so we have not done there. Similarly, I guess if limit is not there, then we have not reduced this one. So these two things we have to reduce. Okay, then only then only it will avoid the details, right? Remember I told you that we have to uh, if 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 consecutive ones are coming, then we have to remove, and if the if the we have to remove the invalid sequence, right? So either the invalid sequence will be if the limit is exceeding. So both cases we have to avoid, here and here, both places you have to avoid that, right? Means we have to subtract the invalid cases, right? If too many consecutives is coming, you have to remove either for the ones or for the ones. Okay, I guess this will work. Okay, let's check, keep checking. So the thing is we have check dp minus this. Okay, If limit is j is greater than 0, we just remove that part. Yes, then we'll check. Okay, I, j, and the last bit. Okay, then we will taking the mode. Correct. If the last bit is this one, let me check, guys.